Welcome to the SmartKeys podcast. Businesses today spend about $450 billion globally on enterprise software.
Which is a lot of money.
It sounds massive, right?
Yeah.
Until you look at human labor. The U.S. alone spends roughly $11 trillion on human labor.
Yeah, it's not even close.
Exactly. So you're tuning into a deep dive today where we are looking at why artificial intelligence is no longer satisfied just, fighting over that $450 billion software pie.
Yeah.
It is coming directly for the $11 trillion labor budget.
It really is the single most important transition happening in business right now. We are moving from tools that just make human workers faster to autonomous systems that actually perform the work itself.
And to help you navigate this massive shift, we are unpacking a highly strategic article by Felix Römer. It's titled Vertical AI Solutions, Tailoring Intelligence to Industries.
A great read, honestly.
Definitely. Our mission for you today is to decode the insights from this text so you have a comprehensive professional resource for navigating the future of work. So, okay, let's unpack this, because if we look at the current landscape, everyone from a freelance graphic designer to a Fortune 500 CEO already has a tab open with a generic chatbot.
Right. They're everywhere.
Yeah. So is this article actually arguing that these massive foundational AI models, the ones billions of dollars are pouring into, that they are already insufficient for the enterprise?
That is exactly the premise. And it really comes down to the difference between foundational intelligence and applied expertise. Up until now, enterprise software has been fundamentally passive.
Passive in what way?
Well, you buy a highly complex tool, but it just sits on a server waiting for a human to click a button or input a variable or run a report. Even the generic chatbots you mentioned, they require a human to constantly feed them highly specific prompts.
Right. You have to tell it exactly what to do.
Exactly. And then you have to manually verify every single piece of output. But we are now entering the era of what Römer calls domain agents.
Domain agents. So we aren't just talking about a smarter text generator here.
Not at all. A domain agent is an intelligent system engineered to deeply understand a specific industry's jargon. It knows the unwritten operational rules, the stringent compliance standards, and the highly specific workflows.
Oh, wow. So it actually knows the business.
Yes, they don't just generate text, they act autonomously to execute regulated tasks. They know the context of the business without you having to explain it in every single prompt.
To put that in perspective for you, the listener, asking a generic AI to brainstorm a few subject lines for a marketing email is a pretty low-stakes game. But if you need an AI to analyze a highly complex commercial insurance claim and decide on a payout, well, you are dealing with a totally different universe of financial and legal risk.
Exactly.
You need a system that intrinsically understands the boundaries of that specific industry.
Precisely. And there's brilliant data in the text from White Star Capital that proves businesses already know this. They analyzed their portfolio firms and found a massive divergence in how AI is actually being deployed.
What do you find?
Well, as you would expect, 96% of these firms are paying for horizontal generic tools. Things like ChatGPT for general writing or GitHub Copilot for coding.
Which makes sense. Those are practically utilities at this point.
Exactly. But here's the critical shift. A staggering 69% of those same firms have already gone beyond the generic models. They've built their own custom vertical AI systems tailored strictly to their own core operations.
Wait, 69%? That is a massive percentage.
It really is.
It means the vast majority of forward-thinking executives looked at the best generic AI in the world and said, well, this just isn't good enough for our actual product.
Yeah, they need something specialized.
So how are they mechanically bridging that gap? Like, how do you take a generic model and turn it into a domain agent?
The text highlights three core mechanisms driving this transition: fine-tuning, leveraging proprietary data, and something called retrieval augmented generation, or R.
Let's break those down, because I feel like the jargon gets incredibly thick right here.
It definitely does.
If I am an executive trying to implement this, what is fine-tuning actually doing beneath the hood?
Think of a foundational AI model as having a generalized understanding of the English language. Fine-tuning is the process of adjusting the actual internal mathematical weights of that model by feeding it thousands of highly specific examples from your industry.
Okay, so you're changing its brain, essentially.
Yes, you are structurally changing the model so that it naturally speaks in medical shorthand or legal phrasing rather than just conversational English. It alters the AI's core behavior.
And how does that differ from RAG? Because I hear retrieval augmented generation constantly thrown around as the ultimate solution for enterprise AI?
Our RAG is entirely different, and frankly, it is the more critical technology for most businesses. Instead of changing the AI's internal brain, our RAG gives the AI a highly secure, restricted search engine.
Oh, I see.
Imagine giving the AI an open book test. Before it is allowed to generate an answer to a user's prompt, the system forces the AI to retrieve your company's specific proprietary data.
Like internal compliance manuals or a specific client's contract history.
Exactly. It reads that secure data in real time and then augments its answer using only those verified facts.
I see. So it basically prevents the AI from just guessing based on its general internet training.
Exactly. It grounds it in reality.
A horizontal AI is essentially like hiring a brilliant polymath intern. They read every book in the world, they aced all their college exams, but on day one, they don't know where you keep the server password.
No, they don't.
They don't know that your biggest client hates bullet points, and they certainly don't understand your specific compliance pipeline. But a vertical AI, powered by ARG and proprietary data, is the 10-year veteran. It isn't just about knowing facts. It's about knowing exactly how things are done inside your specific four walls.
If we connect this to the bigger picture, what you're describing with that 10-year veteran is what the enterprise software industry calls a defensible moat.
A defensible moat, okay.
This is a crucial strategic concept from Römer's article. Anyone, including your biggest competitor, can buy an API key to access a generic foundational model. That intelligence is commoditized.
Right, there's no competitive advantage if everyone has the exact same intern.
Exactly. But your competitor does not have your 10 years of historical customer interactions, your specific issue resolution pathways, or your proprietary feedback loops.
That makes total sense.
When you bind deep domain knowledge to your specific historical data sets using ARG, you create a workflow advantage that simply cannot be copied. You lock in higher accuracy, and as the agent works, it generates new data, making your system even smarter. It is a compounding advantage.
That makes perfect sense for how these systems know what to do. But knowing things doesn't actually complete tasks.
No, it doesn't.
And this brings us to a really fascinating shift in the text. We've established that vertical AI understands the deep context of an industry, but how do these agents transition from just being smart assistants to actually executing the labor autonomously?
This is the shift from systems of record to systems of action. For decades, your tech stack, whether it is a customer relationship management tool, a CRM, or an electronic health record system, an EHR, has essentially been a highly organized digital filing cabinet.
It just holds the information.
The data just sits there. The system is entirely passive until a human worker reads a document, types the data into the fields, and hits save.
So the human is the orchestrator.
Right. But domain agents act as the orchestrators themselves. They don't just wait for a prompt to generate text. They are given a broad goal, and they autonomously plan the multi-step actions required to achieve it.
Wow. So they can string things together.
Yes, they can call different software APIs, extract data from a PDF, run a calculation, and then independently update those old systems of record.
The source highlights some incredible real-world examples of this orchestration. Take the company even up in the legal sector.
Oh, that's a great example.
Yeah, they are using AI to perform associate-level legal review. But it's not just reading a document and giving a summary. The agent is actively extracting specific legal obligations, cross-referencing them against a risk matrix, and flagging clauses that violate the firm's specific standards.
Or consider the scale of what Klarna is doing in customer service. The article notes that Klarna managed to handle 2/3 of all their customer service chats in a single month using an AI assistant.
2/3, that's huge.
And crucially, they maintained human-level customer satisfaction scores while doing it. The agent isn't just suggesting a reply for a human representative to copy and paste.
Right, it's actually doing the work.
Exactly. It is diagnosing the issue, checking the customer's hooking data via an API, executing the refund if it meets the policy criteria, and then updating the CRM ticket. It performs the entire life cycle of the task.
But wait, if I put myself in the shoes of a chief operations officer listening to this, I am terrified.
Why is that?
So, what does this all mean for our current tech stack?
Yeah.
Are businesses expected to just rip out their expensive legacy software to make room for these agents? Because if that is the requirement, no one's going to adopt this.
That is a highly valid fear, but the insight from the venture capital firm NEA, highlighted in the text, offers a massive strategic relief. Businesses do not need to rip and replace their foundational software.
Oh, thank goodness.
The insight here is that AI agents often act before the data even reaches those rigid legacy systems.
How does that work mechanically? Like, where does the agent live?
Think of the agent as an intelligent layer sitting right at the front door of your existing software architecture. Let's say a messy, unstructured email comes in from a client requesting a complex policy change.
Okay, a pretty standard scenario.
Instead of a human reading that email and manually clicking through 5 different screens in your old, clunky CRM to process it, the agent intercepts the email.
It grabs it first.
Yes. The agent reads the intent, orchestrates the workflow, gathers the necessary data, and verifies the output. Only after the heavy lifting is done does the agent use a standard API to send a clean, perfectly structured update into your existing CRM.
Oh, I see. You capture all the value of AI without having to rebuild your database. It's an integrate first, replace later strategy.
Exactly.
The agent does the messy translation work so your legacy system doesn't have to change.
It's spot on.
Which perfectly transitions us into exploring what happens when these systems collide with the truly messy, high-stakes realities of physical industries. It is one thing to process a refund for a sweater. It's another thing entirely to deploy AI in healthcare or heavy construction, where the margin for error is essentially zero.
The applications in these fields are arguably the most remarkable precisely because the real-world inputs are so chaotic.
The text mentions a healthcare company called A Bridge, which integrates directly with Epic, the massive medical record system. How does an AI safely navigate the chaos of a doctor's exam room?
It comes down to semantic understanding. A bridge doesn't just act as a raw transcription service. It listens to the natural, meandering conversation between a clinician and a patient.
Which can go all over the place.
Right. The AI has to mechanically untangle that audio. It distinguishes between the patient casually mentioning their weekend and the doctor making a critical adjustment to a blood pressure medication.
That's impressive.
It extracts the clinical entities, structures them, and maps them directly into the correct drop-down menus in Epic. It effectively eliminates after-hours charting, which is one of the primary drivers of physician burnout today.
The construction industry example with trunk tools is just as wild. Imagine a massive commercial build. You have a site manager dealing with a clash between a plumbing line and an electrical conduit.
A nightmare scenario.
Traditionally, they're walking back to a trailer to physically flip through a 3,000-page architectural spec binder.
Or using a basic digital keyword search that brings up 500 useless results because it just looks for the word pipe.
Right. But Trunk Tools links massive platforms like Procore and Autodesk to an AI agent. It uses semantic search across all those CAD files and blueprints. So when the manager asks the agent how to resolve the clash, the AI understands the spatial relationship of the infrastructure.
Yeah, it retrieves the specific engineering tolerances and provides a highly contextual answer instantly. We also see this in public safety, where Axon is using agents to ingest chaotic, real-world body cam footage and immediately structure it into rapid, auditable police reports.
That's a huge time saver.
And in the financial sector, the article points out that property and casualty underwriters currently spend only about 30% of their time actually analyzing risk.
Wait, what are they doing with the other 70%?
It is pure administrative friction, hunting down documents and manually reconciling inconsistent data. Domain agents are stepping in to ingest those massive, messy submissions and synthesize the text, allowing the underwriter to actually underwrite.
Here's where it gets really interesting, but also a bit daunting. In a hospital or a 911 dispatch center, a hallucination or an error isn't just a typo, it's critical. How on earth do we trust these systems to act autonomously?
This raises an important question, and it is the absolute crux of enterprise AI. You cannot just deploy an agent into a hospital and hope it gets it right.
Obviously not.
The article breaks down IBM's guidelines for enterprise AI, and the absolute non-negotiable foundation is governance.
What does governance actually look like at the software level?
First, it means strict, unalterable audit logs. When an agent makes a decision, it must save its chain of thought reasoning into a secure database.
You can audit it later.
Yes. If an AI approves a legal clause, an auditor needs to be able to click on that approval and see exactly which paragraph in the historical company data the AI referenced to make that decision.
That's crucial.
Second, it requires highly secure, isolated APIs to ensure that sensitive patient or financial data isn't leaking out to train a public model.
Traceability and security. If something goes wrong, you don't just shrug. You look at the exact mathematical breadcrumb trail the agent left behind.
Precisely. But the most vital mechanical safeguard mentioned in the text is the human-in-the-loop architecture. You design the agent so that it constantly calculates its own confidence score for every action.
How does that work in practice?
If the agent is processing a routine, highly repeatable administrative task and its confidence score is 99%, it executes the task autonomously.
But what if it hits something ambiguous, say, a rare medical complication or a completely novel legal argument?
The second the task falls below a predefined confidence threshold, say 85%, the system automatically halts. It does not guess.
Oh, that's smart.
It writes the entire context of the task to a dashboard for a human professional to review. The human acts as an editor and an exception handler. You keep the human in the loop for the complex, sensitive edge cases, while safely turning over the mundane, repetitive volume to the autonomous agent.
So we aren't automating the human out of the building. We are elevating them from data entry clerks to high-level editors. Now that you, the listener, understand the mechanics, the value, and the safety guardrails, we need to talk about implementation.
The hardest part, really.
Exactly. How does a company actually build this without failing miserably?
The source provides a very clear, pragmatic playbook, and the first reality check is acknowledging the difficulty. The text notes that 56% of companies find integration to be their top hurdle.
Integration, not the AI itself.
Right. It isn't the AI that fails, it is getting the AI to communicate securely with their messy, customized internal databases.
Which is why the strategy has to be finding what the article calls a wedge. You don't try to reinvent your entire supply chain on day one. You find a single, highly repeated, painful workflow. A wedge could be implementing that semantic document search for your legal associates, or deploying a highly contained voice agent to handle initial intake calls for a home services company. You prove the technology works on one specific pain point, you measure the ROI, and then you expand.
And as a business expands past that initial wedge, they inevitably face the classic enterprise dilemma. Do we build our own bespoke AI system, or do we buy an off-the-shelf software solution?
Always the big question.
Römer's article offers a highly practical rubric for evaluating this. When assessing AI tools, they recommend weighting the criteria very specifically. Output quality should drive 90% of your decision. Usability sits at 65%. And price is weighted surprisingly low, at just 38%.
That weighting is fascinating, but it makes sense. If an AI is cheap but hallucinates 10% of the time in a corporate environment, the cost of human remediation completely wipes out any savings.
Exactly.
And why is usability at 65%?
Because of that human-in-the-loop requirement we just discussed. If the interface the human uses to verify the AI's work is clunky and slow, you lose all the efficiency gains. The human experience of interacting with the agent has to be seamless.
But let's talk about the cost of building your own model. A few years ago, training a foundational model from scratch was something only Google or Microsoft could afford.
That reality is shifting rapidly. The venture capital data notes that compute and training costs are plummeting. The article references the DeepSeek V3 foundational model, which was trained at an incredible scale for under $6 million.
Wow, just $6 million.
Now, $6 million is still a massive investment, but in the context of global enterprise IT budgets, the ability to train a completely custom foundational level model for that price changes the math entirely.
That's a game changer.
It really is. It means mid-sized enterprises with incredibly strict compliance rules can actually afford to own their base intelligence rather than renting it.
Which brings up a fundamental shift in how businesses are going to pay for software moving forward. It sounds like we are moving from a traditional SaaS model, which is like paying a flat fee for a gym membership, whether you go or not, to outcome-based pricing, where you only pay when you actually lose the weight.
That's a perfect analogy. Outcome-based pricing is like hiring a digital contractor instead of renting the tools. You don't pay for access to the tool, you pay for the completed job.
You pay when the verified work is actually completed. If an even-up agent reviews a complex legal document, the law firm pays a fee for that specific completed review, not a blanket monthly subscription to have access to the dashboard.
And this mechanical shift in pricing is exactly how AI is crossing over to access that $11 trillion labor budget we discussed at the top of the show. You are no longer budgeting for software licenses. You are essentially contracting digital labor.
It completely rewires how a CFO calculates return on investment. So if a business is mapping out their technology strategy today, what is the ultimate architectural recommendation?
The consensus in the text is definitive. Rely heavily on RAG. Businesses should almost always start by using retrieval-augmented generation to give existing models access to their private data.
Is the most practical step.
It is drastically cheaper, it is faster to deploy, and it safely solves the vast majority of domain adaptation needs. You should only spend the millions required to fine-tune or train a custom model from scratch when your operational data is completely alien to standard models, or when strict regulatory compliance mandates that you have absolute offline sovereignty over your AI architecture.
Start with a wedge. Use RAG to safely feed the AI your specific context and only build from scratch if the law requires it.
That's the playbook.
This has been a masterclass in how vertical AI is mechanically rewiring the fabric of industry. As we wrap up this deep dive, what is a final thought you want the listener to take away as they evaluate their own company's readiness?
Think carefully about the fuel that powers these systems. We've talked extensively about domain agents becoming the new central nervous system for business operations. But an agent is completely useless without structured knowledge.
Right? It needs data.
Right now, companies generate mountains of unstructured data. Messy text logs, disorganized customer call audio, raw field service images. Historically, that data was considered digital exhaust. It was just archived and ignored.
Because it was too expensive for humans to sit there and categorize it.
Exactly. But moving forward, the companies that are meticulously capturing, curating, and tagging that unstructured data today are the only ones who will possess the proprietary fuel necessary to train the autonomous workforce of tomorrow.
Wow.
It is a race to build the data feedback loop. The data you ignore today is the automation you forfeit tomorrow.
The data you ignore today is the automation you forfeit tomorrow. That is a brilliant and urgent reality to walk away with. Thank you for tuning into the SmartKeys podcast. We really hope this deep dive gave you the strategic clarity and the technical understanding you need to navigate this historic shift from passive software to proactive agents. If you found this breakdown valuable, please subscribe to the podcast so you never miss an insight. And I highly encourage you to read Felix Römer's full article to explore these concepts even further. You can find the direct link waiting for you right in the show notes. Until next time, keep exploring and keep learning.